Welcome to Knowledge Graphs, Ethics and Community Record Keeping, a presentation for the Ambassadors Virtual Unconference BGI-25. Graph algorithms supporting ethical AI in community governance. In this presentation, I'm going to cover the topics outlined below. If you can read the slide there, I won't read them all out, but then I'll dive in to each one in turn. Okay, first of all, participatory design and co-ownership. Community members should be involved in establishing what their data means to them and how it represents them. So, what data means could involve community detection, clustering, like Louvain analysis, Leiden, or modularity, to reveal which clusters of users contribute to documents and whether participation is balanced or dominated by subgroups. So, how the data represents participation entropy. So, this could be things like diversity metrics on degree distribution, and to quantify diversity, high modularity, distributed degree, and healthy co-ownership. So how does the community interact? That would be things like betweenness centrality could be helpful in identifying bridging participants to identify users who bridge multiple communities who are key facilitators of participatory design. Okay, next we move on to transparency and auditable traceability. So every change needs to be auditable and traceable using open source version control. And this can be verified through pathfinding or provenance checking, including breadth first searches or depth first searches, which can generate transparent provenance chains of edits, who influence which documents. And things also could use temporal graph traversal. So temporal laying can show how transparency has evolved over time. And then we move on to permissioning and role separation. So role-based subgraph extraction can help you identify roles such as reader, commenter, editor, and reviewer, and filter those roles. And centrality and authority analysis, including using algorithms like eigenvector, PageRank, can help detect concentration of powers and identify over-centralized users who may have high page rank in the permission graph and potential concentration of power. Conflict resolution and appeals. There needs to be a dispute process, so a structured process for disputes about archival content, edits, and the framing, and a mediation and a peer review or consensus overrides. Flow influence propagation, maximum flow random walk to a trace, mediation outcomes. Bias awareness and meta-governance. Archivists should audit language, omissions, and framing biases. There should be regular meta reviews of the archive itself, including bias audits, and equity checks. Weighted graph analysis include for positive and negative sentiments or agreement. And graph embedding and clustering using techniques like using tools like Notivec or DeepWalk for latent bias communities to identify, to use embeddings to find semantically similar content groups dominated by one demographic or viewpoint. Resilience, succession, and documentation. So there needs to be clear onboarding, backup, and handover. So passing the torch protocol. To avoid single points of failure by having multiple maintainers and to ensure redundancy, so each critical document should stay connected to multiple maintainers ideally. And you can graph again temporal evolution like churn rates, degree of persistence, to track continuity across time slices, and to measure institutional memory. Minimal intrusiveness and safety defaults. Anomaly detection can help detect abnormal edit patterns, so too many automated suggestions accepted without review. Causal subgraph extraction, to understand AI suggested edits, explain why an AI suggestion was accepted or rejected, and maintain safety thoughts by flagging anomalies rather than executing them automatically. Context sensitivity and local norms. Quantify how cultural or linguistic subgraphs influence each other. Heterogeneous graph embedding. So look at the different graphs, how they can embed in terms of different communities. Community detection by locale or language to ensure local contexts are represented in global governance by detecting underconnected regions. Reveal norm diffusion, how different groups influence each other, which contexts adopt others' ethical framings over time. So how can we implement these methods? What a logarithmic workflow would we use? First of all, we would construct a base graph with nodes such as users, edits, documents, roles, contacts, and issues, and edges such as authored, modified, approved, disputed, has role, or has context. Then we would annotate that metadata by adding things like weights of trust scores, recency, frequency, sentiment or bias tags, and locale. Then will run principal aligned analysis like modular to run Louvain analysis for participation or PageRank for power balance, and temporal snapshots to capture change in structure. Then we may generate metrics, dashboards, or reports, such as participation diversity indexes, transparency scores, bias, entropy, robustness index, anomaly score, etc. Then we would feed those insights back into governance by sharing those dashboards or reports with the community so the contexts get updated or approved and a new graph version is created which can then be iterated upon. So what would this look like in practice? What would an example composite analysis look like? What if our goal was to detect imbalance in participatory governance? The logarithm chain might look something like this. To run a Louvain community detection to identify participant clusters, to compute participation diversity using Shannon entropy of cluster sizes, to overlay PageRank such as role influence to highlight dominant nodes, to combine with language-based associativity to see if dominance correlates with region or language. And if an imbalance is detected, to flag participation bias issues and propose context or policy updates to update the underlying graph. Okay, well, thank you for listening to this presentation. You can find us on QADAO Twitter or this YouTube channel, QADAO YouTube.